This is Kumar Singh from Design Analytics LLC, and you are watching another episode of Throwback Thursdays. Well, the historical context of the topic that we are going to explore today is linear programming, right? And specifically, one method used within the world of linear programming to solve linear programming problems, right? But before we start exploring that, let me start a story actually. I'll start the story, then pause it, then we will resume it somewhere again in the middle of the video, and therefore at that point we will understand the context of the story, which is a true story within the realm of the history of linear programming, right? So the place is University of California, Berkeley campus. 1939 is the year, right? So near the beginning of a class, Professor Jerzy Neiman, he writes two examples of a couple of famously unsolved statistics problem on the blackboard because students were asking him for some examples. First year doctoral student who was late for the class kind of sneaks into very late in the class, and he mistook the set of unsolved problems there on the blackboard as homework questions, scribbles down the questions, right? The name of the student was George Danzig, and those of you who know now know, right, why I have started this particular video with this story, right? So he scribbles them down and he solves them over the next few days. Actually, he solves those problems that have not been solved before. So he found these problems slightly harder than normal homework assignment, and then he basically goes and puts the solutions on the desk of the professor, right, and forgets about it. Let's pause the story there, right? Let's go back to exploring the origins of linear programming. So origins of linear programming can be dated back to I would say around World War II, right? Namely in the field of economics and with Soviet economist Leonid Kantorovich. I hope I said the name right. If I didn't, I apologize. So in 1939, around the same time that when the Dantigs thing happened, Leonid developed the first forms of the linear programming problem for organizing and planning production, right? He's widely cited as a founder of the field, right? And his method, known as Kantorovich's method, revolved around finding dual variables and corresponding primal solutions. So I'm assuming familiarity with these terms, right? Because we are focusing on the historical aspect. Though we'll touch upon an example of the solution space, right, very quickly. But I assume that most of the listeners are familiar with these terms, right? So the method revolved around finding dual variables and corresponding primal solution, and linking how the results from one directly impact the other, right? Now, the ideas of primal and dual simplex are, as you may know if you're familiar, key components of linear programs. However, they consist in a slightly adapted form from what was originally designed by Kantorovich, right? Kantorovich would later go on to win the Stalin Prize for his work in, I think it was the work in resource allocation, stemming from the ideas he developed in the operations research. Another important character to this field, among many others, was John von Neumann. He was basically a rock star in the mathematical world, right? He dabbled in a variety of topics ranging from quantum mechanics to game theory to the early days of computer science, and most importantly to us for this video, linear programming, right? So he contributed an important aspect to this field known as duality theory, which involves the idea of primal and dual linear programs, right, that we just touched upon. Now, without explicit knowledge of what this entails, I think what is important to understand is that this concept is pivotal to expanding and solving more complicated linear programs and highlighting a connection between optimization by maximizing or minimizing. So these figures, right, they crafted a field in which decisions of optimality can be expressed simply as a set of linear equations, right? But a key issue still remained: how do we solve these, right? How do we solve these? And that's where we go back to finish the story that we started, where that guy submitted the homework, quote unquote homework, put it on his professor's desk, right? So in Danzig's own word, about 6 weeks later, one Sunday morning, about 8 o'clock, my wife and I were awakened by someone banging on our front door. And it was Professor Neyman. I think he recalled this in a 1986 interview, right? So basically what the young back then, had done, unknown to him, was solve these statistical problems, and they had a giddy professor already writing his papers, introducing him to the publications. And from here, his journey into mathematical stardom began. 8 years after this tale, forever ingrained into the mind of wannabe mathematicians, Danzig was working as a mathematical advisor for the Pentagon. He was tasked by his department to computationally speed up logistical issues faced by US Air Force, and he developed techniques stemming from the inherent field of linear programming to optimize those challenges. The method used was to be known as the simplex method, and that should bring smile to the faces of every operations research enthusiast, because that's a method we have had good and bad times solving, because at least when I was in college, these methods, you had to solve some of them manually in the exams, right? So what does a typical problem look like? We'll not get into the details, like I said, but a quick example of what an objective typically could look like is, basically it's a goal you are trying to reach to that goal given certain relationships and constraints, right? So think of a fruit seller figuring out how to maximize profit with different fruits having certain purchase restraints, cost requirements, life expectancy, etc., right? So while these problems may not have been the most critical problems for Danzig at that time, these motivating ideas at least warrant some kind of solution that is optimal, right? And his simplex method of 1947 did just that. And to his own surprise, actually, it has an incredible track record for being an effective method. So you see an example here, right? It's a quick GIF, right? Showing how the objective function, which is the purple line, speeds towards the optimal solution. So it's speeding towards the optimal solution, and the method, basically simplex, works by navigating on the vertices of a feasible region which contains solution or solutions that exist, right? And then decades later, where now it's, or almost more than half a century later, where it's commonplace for new methods to come in and improve on the old, finding unique and novel ways to push the boundaries, the simplex is still regarded as a strong contender for the best method at solving linear programs, with most industrial solvers still employing the 75-year-old method. Well, thanks a lot for watching. I'll see you again next week.